Okay, mathematicians, today we are going to be doing a really quick review of how to find the area of a parallelogram. So at the top of your page, if you take out a piece of paper, or you can do this screen side by side with Notability, make sure we label. Now, as a quick review, just in general, remember that area is talking about the amount of square units it takes to cover some sort of surface. So when you started with area, a lot of times students will start with just rectangular figures, and it might just be split for them. So here we can see some squares in an array, and we can see that it is 3 squares down and 5 squares across. So we could either count all the squares, or we could say that 3 times 5 is 15. So its area would equal 15 units squared. And then you move on because you start to realize that there's this pattern that you can multiply the array, and we move to more abstract type of problems, meaning that the squares aren't drawn in. So we might have an example that looks like this, and then you just have a label that maybe this is 4 and this is 2. One option is you could obviously draw in all of the squares, but most of us at this point have learned the formula is that area is equal to, of a rectangle, length times width. So in this case we could do 2 times 4, so it would be 8 units squared. Now this is the one that works for rectangles, but you aren't always going to be working with just rectangles. So we're going to look at how it differs when we start to look at parallelograms. So if you remember, a parallelogram kind of looks like a rectangle that's been blown over a little bit, so it's slightly tipped. You can almost think of it in a couple ways. We could sit there and think about cutting this piece off and then moving it over here and adding it there, and now you would have this new rectangle. So it's very similar to finding the area of a rectangle, but the difference is that what often confuses people is that this length right here is not the height of the parallelogram, that the height of the parallelogram is actually the distance between the two bases. So as we're looking at this, this could be the height right here because it forms a 90-degree angle with the base, or it can be dropped down in the middle, once again showing that 90-degree angle. But the length of the base of the rectangle itself never changed. So when we find the area of a parallelogram, and this will still use and work for a rectangle, we're actually going to now use base times height instead of length times width. So let's look at an example. If I have this parallelogram and you were given these measurements, once you go ahead and pause the video and see if you can figure out what the area of this parallelogram would be. Alright, because we're finding the area of a parallelogram, we're going to take base times height. So the base of our parallelogram is pretty clear. It's going to be that 2. So I'm going to start by taking 2 times, and now we just have to determine what the height is. If you remember what we talked about before, the height isn't going to be this slant distance. It has to always be measured at that 90-degree angle. So in this case, my height would actually be 3 inches. So I'm going to take 2 times 3, or my area is going to be 6 inches squared. If you have any questions, go ahead and drop them in the comments below, or you can send me a message on Schoology. Otherwise, go ahead and get these notes put into the place where you are keeping them.